Really the biggest change is the application of some constraints. That's probably the short answer. We sit in this unique position of seeing what people's cloud journeys look like across the globe as a company that is an enabler of cloud. We're in this information flows that shows us how people are doing it, and I think we talk about it that there's a stage 1 of cloud and then there's a stage 2, and I think the stage 2 is being accelerated. Stage 1 is when people first just go sign an enterprise agreement with Amazon or Azure or their cloud provider of choice, and they start building applications because there's a lot of good reasons to do so. But they do so in a very unconstrained way because their priority is speed. And invariably what happens is 6 months later someone says, well, you've way overspent the budget and your security teams are concerned, and that gets shut down. And I think that when the economy was looking more positive, there was actually less concern. Yeah, we know we're overspending on cloud, but the benefit is we're getting applications out. In the phase 2 model, what you do, and you see this everywhere. There's the application of a cloud center of excellence or a cloud program or platform engineering function, and they go, hold on a second, we're gonna constrain how people adopt cloud. You can continue to use Terraform, but I'm going to apply policy and governance before things actually get deployed. And so they ended up running a central shared service of our products instead of having people at the ends just do that themselves. So I actually think this notion of people running platform engineering organizations or cloud COEs has really accelerated in the current environment because people are realizing how much waste there had been in the prior model. So that trend had been underway for a long time, but I would definitely say it's accelerated. The understanding of overspend is accelerated. So I think in many sense that reflects how we have evolved as a company, where we were at the very, very early innings of cloud and people use our open source projects to do those things in phase 1 of cloud, and it's very unmanaged. And then about 6 years ago, every big company came to us and said, hold on a second, I need to have a central way of doing this. Yes, I want to use Terraform, but I want to apply policy. And that is when we created our commercial products, truthfully. It was in response to that transition. So that's what we do when we say we support hundreds of the Global 2000. That's what we mean. They have progressed to this point where they run our products as a shared service and we support them as a vendor. The biggest challenge most people face is understanding that there's an organizational transition required. I think that's the $1 million question is everybody sort of wanders through the desert trying to figure out how to do this in a consistent way, because it's not about deploying one application, it's about industrializing the process of bringing apps to cloud. And that actually requires you to coordinate ops people, security people, networking people, and developers, so all 4 people in IT. So what people come to pretty quickly is the realization that actually they need to change their organizational structure to allow for that centralized platform engineering function. And then they run ops, security, and networking aspects, and then all the application development teams can deploy whatever apps they like through that model. That is probably the single biggest change that people have to make as an organizational one, and that just takes time for people to come to, but it is the model. So the question around cost management of your cloud estate is one that's become a much bigger issue in the last 6 months in particular. And I think most of us realize that in the unconstrained world, we're all overspending on cloud. And in effect, that was okay, given the interest rates were low and opportunity cost was high of slowing things down. And so as the world's gotten tighter, this notion of optimization of your cloud estate has really been a focus area. And you see that in the hyperscaler revenues, where everyone made really big commitments to the hyperscalers, and what you've seen is actually a slowdown in their growth rates over the last 6 months, which in my mind is reflective of that optimization cycle that's happening. And people call that FinOps, to constrain that. Well, it turns out the way that you actually control the costs on cloud, first and foremost, is by not letting people provision things. And it turns out, because our products are the standard globally for how people provision compute, the way that people are doing FinOps by and large, they may have some analytics to tell them, hey, what's going wrong, but the way they correct it is by deploying infrastructure using Terraform. So in a sense, our products are at the heart of the FinOps movement in as much as they are the workflow that is used to remediate overspend. And I think sometimes that's harder to explain, because what we do is a very, our products are used by detailed practitioners that understand technology well, and it's sometimes harder for people to step back and understand, actually, no, Terraform is fundamentally the provisioning mechanism for all infrastructure. So if you want to constrain the spending on infrastructure, it is constrained through Terraform, and that's where that's what our customers do. So yes, Terraform is what we're often most known for, but actually Vault and Console are almost equally popular, believe it or not. They're just not desktop tools that people can see, but in terms of downloads, there's not that big of a difference. So our products are designed in the Unix philosophy of one product solves one problem, and then the next product solves the next problem, and you chain them together if and when you need to. So people start with Terraform very often to automate the provisioning process, but then what they realize is actually now I've enabled people to be able to deploy and provision things outside of my data center really easily, and now I've created a security challenge because I now have things out here which are running potentially on the public internet. So it introduces the security problem that actually didn't exist when everything was being deployed to the private estate, because in the private estate you have a secure network perimeter, and it's a very well understood security model. Everything getting provisioned is safe because it's inside your data center. The default model outside is it's not safe, and so you almost immediately run into the need for Vault once you start using cloud, because you want to authenticate the identity of every machine before it talks to every other machine, and to determine if they're allowed to talk. So you kind of walk your way up the problem domain as you move along. So generally people start with a Terraform problem, then they realize they need to solve the security problem of cloud in a cloud agnostic way. And then then they run into the networking problem, which is, hold on a second, I've now have people's ability to provision compute, but how do I actually update the networking rules for what just got deployed? So it's almost like Lego pieces that logically are designed to fit together. They were designed to be used together. We actually disaggregated them about 7 years ago, but because that's how enterprises want to adopt them. But in truth, the combination of Terraform, Packer, Vault, Console is the stack that most people use in the end. So in a sense, what our products solve is an integration problem, which is a fascinating, but I actually worked in middleware product development a long time ago, and the hardest part of playing that role is the scale of connectivity points to you. Every time Amazon releases a new service, someone has to update the Terraform provider for Amazon to include that new service. And so you multiply that problem times every connection that you've got in the world, it's an infinitely impossible problem. And honestly, one that can only get solved in open source. So the simple answer then is what we do is our products have integration surface area that we make available to people. And then actually, as the market has standardized on our products, we don't do that work anymore. So when Google releases a new database service or a new messaging service, as part of their release process, the team at Google updates the Terraform provider to ensure that it's compatible with the new thing. Why? Because all of their customers use Terraform. Same at Azure, and then go down the list. So we've solved the integration problem by using market forces combined with open source, which is, if you think about it, it's a real learning out of the middleware world, where it was very difficult to keep up to date with the adapter. Where it was very difficult to keep up with the adapter ecosystem. And it's been an amazing thing to watch, actually. I mean, there are over 3,000 Terraform providers alone, and we don't really work on many of them anymore. And I think that's the market rule that we were trying to have. We think that there's real value in standardization, and it's good for everybody. And that's why it's done in open source. It's good for everybody if there's one way of provisioning, one way of doing identity-based access. And then over time, as every large company in the world has said, hey, I use Terraform, I use Vault, every vendor in the ecosystem has said, okay, fine, I will build and maintain the integration because that's the market standard. Now, they're not going to do it for two, they're going to do it for one vendor. And I think that's the real value of why a vendor needs to play this role, because if you're a big company, you have that integration problem, and so you actually need a third party to drive that standardization in the industry so that you can benefit from it. And just know, if you use Terraform, yes, you can use it for everything from Amazon to networking estate to private data center to SaaS applications, because the market forces will make that happen. So obviously our products live in open source, and if you look at the GitHub repositories, you can just see the velocity of contributions that come from the community. I mean, if you're just were to look, you'd see like every few minutes, literally, there's an update to an element, and a lot of it's because of the provider ecosystem requires it. And so I think the most visible thing to us is the importance of that community in the open source world of provider development. And we get alerted by our customers to, hey, this is a capability that we need. Maybe I'm working with Snowflake, use them as an example. Every day we get ideas from that community who's contributing either contributions to our core products, which we may or may not accept, or requests and integrations into the Terraform provider ecosystem or the Vault system backend ecosystem. And I think that's probably where it comes from most. It's sort of the contributions. I mean, Vault, to be clear, Vault has an incredibly extensive ecosystem in the same way that Terraform does, again, because it's the market standard for this model. So, the identity backend for say things like Alibaba, a good example, like they do that work, they contributed. The system backends for Snowflake and Databricks and all the MongoDB and all the modern data management technologies, they do that work and contribute them to us. And I think that's the beauty of the open source model. The HashiCorp value proposition is incredibly simple. It's about enabling consistency of how people run infrastructure. And I think there are many, there are historical parallels to this. I think in the prior generation, the role that VMware played was around enabling standardization across the top of 4 or 5 or 6 different major hardware providers in the server landscape. Now in the cloud model, and the reason that was required is because if you're a big company, you can't have 2 ways of provisioning compute. You need one. You can have different suppliers underneath, but you need a common layer across the top. And our role is actually very analogous to that in terms of the problem we solve is one of enabling operational consistency. Now, obviously, the cloud providers are not dumb compute providers in the same way that a HP box is. They have a rich array of services, so the relationship's slightly different. We're not trying to create a lowest common denominator. We're just trying to create a common operational approach. So the way I provision compute, the way I think about zero trust across Amazon and Azure in my private data center, that is what we do. So we are unique in that we play that role for the vast majority of the companies in the ecosystem, and that's a role that the market needs played. Like it or not, everybody's going to have more than one piece of infrastructure, even if that's just Amazon plus their private estate. And that's what we do. And I think like a really good example, if you think about it, most often people aren't moving all things to cloud. A lot of things are staying on private data center. Your core systems are going to stay in your private data center, but your new things you're building are going to be built on cloud. So say, for example, I have a mobile banking application I'm building. That's probably going to be built on a cloud platform for all the good reasons that it should. But the core database that it connects to is going to live in your private data center. And Amazon really only cares about that walled garden of itself, but the customer has that Amazon plus their private data center, and it needs somebody to be able to play the bridging role of how do I broker the connection between those two things? How do I create an encrypted connection between those things? The market needs somebody to play that role, and that's what we do. So this is a different event for us in that we have previously had a singular event in Amsterdam, and rather than making everybody travel to us, we're traveling to others, and we're doing this simultaneously. So that's new for us. I think there was a period where we couldn't really engage with the community all that well because of COVID, and we're trying to get back in front of that. I'm always struck by the sheer scale and number of practitioners and people that earn a living on our technologies each and every day, and this is a way that we can go and contribute back to some degree by having them come and learn what's new, and we catalyze introductions to their peers, and ultimately it's a community event. But at the same time, as we've gotten larger, there's also a lot of really, really big companies here that are here to also meet with their peers and understand the value proposition for why they should adopt these kinds of technologies, because they're all struggling with these same problems. So it's really a combination of those two things. It is a demonstration to our community of practitioners that we are here to engage with them, and we value their engagement, and they are extremely important to us. And then it's about the larger companies in the region, and some of the biggest companies in the world are based here, and many, if not most of them, already use our technologies, and so it's our opportunity to engage with them. I think it's if there's a third one, it's actually super interesting to me. It's a way for us to demonstrate the model that we run. You know, we're a public company, so you can see what our revenues are. Those revenues come from the larger companies in the world, and we use that revenue to reinvest in making the products better for the community. It's that circular model, and that's why, you know, it's a beautiful thing to see the biggest companies here that are potentially our commercial customers, but then that's allowing us to fund the innovation in the products that the practitioners use every day, whether they pay us or not, and that's a really, really cool thing to be able to share.